Hello everyone, another episode of me, like coding some stuff. So today we're gonna be taking a look at how you can create a tool to self-register your classes. Basically, just to put a little bit of context, the idea is to create a library that you can attach to the service extension dependency package of Microsoft. So if I do this, I'm just gonna install this and then just change something. If I install this, I just created these two empty projects, and if I remove this, the whole idea is to create a class where we can just call it service collection extensions, and we will provide a single method where we return the service collection at auto registrator. And when we do this, we can automatically register types, interfaces, and many other things using a little bit of reflection. I know that reflection is quite unpopular and people just like, oh, stay away of it. But this is just a fun exercise to do to understand a little bit more about the language and what we can do about it. So basically what I want is to do this, is to use this method to register a set of classes, and I can register their interfaces, all the interfaces that it implements. It can register the type itself, or it can register both the type and the interfaces it implements. How I'm gonna do that? Well, let's just do something and let's go to create a couple of tests, and let's just start with some tests. So I'm going to do add auto registrator with uppercase tests. So I am going to have a test that is going to have a service collection, and the test is going to be add auto registrator. The first simple is like it should not throw. Let's just start with that, something simple. I'm gonna set up auto testing, and there you go, it doesn't throw. That's a little bit silly, but that's the first thing that we want. Now, what else do we want? We want to probably test that it should register types. Obviously, it should register all types in assembly. There you go. So let's see this. Basically, yeah. So we add auto register, then we build the service provider, then we type, and we get our iTest service, and it should have, so get service. I'll just say this, and I will just say, actually this is my service, and then I'm gonna say that my service should not be null. Perfect. So this is the first test that I wanna do. In order to do this, if I need to first create this, I will create the interface, and I'm gonna do get required service because I'm expecting, so I don't have to deal with nullability here. And let's import fluent assertions. Good. Okay, cool. So we have our failing test. We can start from here now. So add auto registrator should register all types in assembly. So I'm gonna actually move this, and I'm gonna just call it test service, and I'm gonna call it a class, so I can actually say that it's a type. I want to differentiate a type and an interface. A type is going to be basically everything that is instantiable, and an interface is basically every interface that the class will implement. So I want to be able to resolve types, whether if it's a record or a struct or a class, and I want to be able to resolve interfaces for them. So that's why I make a difference between a type and an interface. So first thing that I need to do is just make this test passed. So I'm gonna go to here, and I have to be able to pass here a collection of assemblies. Let's say assembly, or I would just first pass an assembly, and I'm gonna make this nullable. I'm gonna pass this, cool. Then the first thing that I want to do is I'm gonna do that what actually suggested. I'm going to get the current assembly, and for each assembly, so basically what I'm doing here is like, if there is an assembly pass, I'm going to use that. Otherwise, I'm going to use assembly get current assembly, and I'm going to check that for every type that is in the assembly, if it's a class and if it's not abstract, I am going to add it as a transient. Good. So now my test passes. Why is that the question, right? Now I'm resolving a test service, and I am able to resolve that because I added my type, basically. Now I want to see what methods do I have here. So I have get exported type, forwarded types, and many things. So what happens if I choose get exported types? My test passes. But what happens if I actually make my class internal? If I make the class internal and I run my test, they don't pass anymore, because get exported types will only be able to see those types that are not internal, so types that are public. And we want to be able to register types that are internal. It's a good practice to make your classes internal only to the assemblies that you're working. So let's go back and let's just leave get types. Perfect. So this is passing now. Cool. So basically I'm just now exporting all the types. Now this is basically working and is doing what I want, which is registering every type that is on the assembly. But we want this to be a little bit more intelligent. I want to be able to say to only register types that I want, because what if I create a library and I only want to expose 3 types, but I declare in that library 20 types? So this is where things start getting fun. So the first thing that we are going to try to do is define how do we want to discover these types. Are we going to use interfaces as markers? Are we going to use attributes? Are we going to use strings to identify them? Well, that question for me is already resolved, and it's going to be through attributes. So if you consider an interface as a marker, for example, if I define a public interface registerable, I can probably use this. I'm not saying that this is what I'm gonna do, but I can just put this registerable, and then I can search here if the type is this and the type has as interface this, we register. Otherwise, we can just have another class that is not registerable, and if I do this, basically I'm gonna create a test that says like it should not register types that don't implement iRegisterable. Cool. then I will actually make this annullable, and I'm going to get test service 2, and here now service should be null. And that's good. Basically, we are using an interface as a marker to discover the services that we want to register. Whether we want to register the interfaces or the type, we can use it. But that's not a good approach. Using the concept of an interface that should be giving us behavior, should drive behavior, using it as a marker is a little bit of a smell. So we are going to use something different, which is quite common for these scenarios, which is we are going to use an attribute. I'm going to create a class called auto register type, and this is going to be an attribute. Now, when we have an attribute, we need to tell it where this attribute can be used. If the attribute can be used in a class, or it can be used in a module, or is used to decorate an assembly or a constructor, where this can be used. So we're gonna say that this attribute can only be used to decorate a class or a struct. So I can actually inject both. So I don't want to tag an interface because I will never register an interface, but I can register a struct. So what I want to do now here is I am going to get all the custom attributes and see if anyone is this. Now I'm gonna save this, and this should make my test fail. Yeah. Because this one doesn't exist anymore. If I save this, now my test will fail because this test service is not implemented this interface anymore. What we need to do is decorate this class with test service, and my test now should pass. That's cool. Perfect. So actually we got the really basic behavior that we were looking for, which is having a simple attribute that is going to allow us to expose into our service collection registrations of types. And now things are going to start getting a little bit funny, because I'm adding everything as a transient. We know that we have 3 different types of lifetime scopes. It could be a scope, it could be transient, and it could be a singleton. How we're going to do if we want to register this type as scope, for example, or singleton. So let's add a test to make sure that we can actually register one type as scope. So if I resolve that type multiple times from the same scope, I will always get the same instance. So I'm going to say that void, it should register types as scope when required. So the test is the same, we just get a type. And now if I want another test too, and this is a get required service, and I'm going to get the test service again, service second instance. So second instance should be actually my service. What I'm doing here is I'm testing that these two are exactly the same instance in memory. So I'm going to test this, and this is going to fail because we are registering all the types as transients. So how can we actually pass the lifetime that we want? Well, we can attribute our classes, so we can just put whatever we want here. So I'm going to add here the service lifetime, and by default I would like to make it scope, so because the scope is the default lifetime that happens on HTTP requests in ASP.NET Core on APIs. So I think it's the natural thing to register things as a scope, contrary to most what other frameworks do, which is register things as transient. So I'm just going to put this as a scope, and I'm going to add I don't like to make this a set, because I want that once the attribute is created, it never changes. So I'm going to remove the setter, and I'm going to create a constructor where I pass the lifetime. I am going to remove the default value, and that's it. So if I do this, now my I have now the lifetime here available, so I can actually register a new service descriptor. A service descriptor, what it does is allows you to generate the registration of a type. So the service descriptor is what specifies the registration in the dependency injection engine. So you can see that it has a service type, an implementation type, and what is the lifetime. So the service type is what is actually going to be in memory once you resolve. The service type is actually what you request to be resolved. It could be an interface or the same type, which is basically this. Now what you actually get here, the instance, is the second parameter, the type. But because we want at this moment to only be focused on resolving types, I'm gonna exactly register the same. Now I'm going to get a variable out of this, and I'm going to get an attribute, and if the auto register attribute is null, I just continue. Now I can remove this expression, because this means that I will only register into my DI those types that have been decorated with my attribute, and that's good, perfect. Now if I run the test, all the tests pass, because now I'm able to register things with the desired lifetime that I want. For example, I can register a singleton. So let's add another test for a singleton. Thank you. It should register something as a singleton when it's required. And how do I know it's a singleton? I can just get another one per instance. Cool. Now I'm going to make a test where I will auto-register a transient. And how do I know it's a transient? All the instances have to be different. See? So I register every type in the assembly. I get one instance of my test service transient, and it should be there. Then I get another instance, and it should not be this. Then I'm gonna get another one, and the new one should not be the first instance. I'm gonna rename this on the file. Yeah, I'm gonna rename this as first instance. Sorry, my dog is here. I have a dog. He wants to be with me while I stream. So this way now we can make sure that we can handle the 3 different lifetimes with a simple property. And that's so cool. In just like less than 20 minutes, we have a working prototype for a simple DI registration tool, doing assembly scanning, doing reflection. So if you were interested in know how to do reflection and access attributes and play with them, it's just this. That's it. There is no magic here. Well, there's a little bit of magic, no? So what can we do here now? Because now we are registering types. What if I want to register the interfaces that these classes will implement? So what I would do to simplify things is I would create a different type, a new attribute. I'm going to create a class autoregister, interfaces attribute. That's it. I'm gonna also decorate this and say that it's a class and struct. And if I want to register a class, but then I want to resolve the interface, I will decorate the class with this and not with the other. So the usage will be basically this. It should register types, type interfaces when required. And here what I do is I am going to create a new class that implements this interface, and I can actually resolve the interface. Good. So I'm going to create this. And let's see what happens. My test will fail. Why? Because we didn't add the correct logic to actually resolve interfaces. At the moment, we are just resolving types. So we need to go and change the code. So what we are going to do now is basically we're going to check that if it has an auto register type attribute, we are going to register the type. Okay? And once we register the type, I will continue. Now I'm going to check if the type is not null. We do this. Now I'm going to check if it has a register interface attribute. Then what I am going to do here is, as you can see, I'm going to use the auto registers attribute lifetime. I need to do at the lifetime here, so I can register a type, and it could be resolving an interface as a scope, a singleton, or transient. But what I want to do actually here is to change the service descriptor for the service type not to be the type that is decorated, but every single interface that this type has. Okay? So what I'm going to do is I'm going to do for each interface that is declared in this type, I'm going to create a service descriptor that is the interface. That's cool. Perfecto. Let's see what it says. Perfect. All my tests pass now. Sorry, I closed the window. So that's what we need to do. And now probably you're thinking, oh, what if I want to register a type? Because sometimes it's really handy if you can do this. I'm going to add a test, which is public void add auto register. It should register type and the interfaces when required. Okay, so I'm going to create another interface called test service interface and type and this should not be null. And the other thing that I want, so basically I'm resolving the interface, but I want to make sure that my service should be a type of this class. So I'm going to create this class. I'm gonna make it internal. I'm gonna make this class implement this new interface so I can resolve an interface, but I also want to be able that when I resolve the type, that they are exactly the same object if you want them as a scope. So what I'm going to do is I'm going to get second instance, and the second instance should be the same service if, only if I auto register the type and interface. Sometimes you want to do this. You want that when you resolve an instance and you resolve the type, that they point to the same object in memory. Yeah, sometimes you want that. It's really useful. So what I'm going to do is I'm going to generate a new attribute that it will register the type and the interface, and I'm going to do the logic here. Basically, the logic is extremely simple, as you can see here. You want to get those types where they have been decorated with auto-register type and interface, and if it's been decorated like this, what you want to do is you want to first register the type, and this will allow that if you resolve the type, it will basically be. But there is a problem here, because what you don't get here is the same object in memory resolving the interface and the type itself, which is what we are testing here. So here we are testing that when you resolve the interface and you resolve a type, both of them point to the same. So we need to do something with the service descriptor for this to happen. So let's take a look at what the service descriptor is doing. And this is actually going to tell us how we can register types and interface in the same way. So if you look the service descriptor, it has several constructors. One that receives a type, one that receives an object, and you have one that receives a function. So basically what I'm going to do is I am going to use this function that receives a service provider, and with this service provider I am going to actually get this object that I register here. So when I do this, I am resolving this guy that is here, and if this has been registered as a transient, it's perfectly fine, because this will resolve this type, and this type is registered as a transient. So we want always a different object, regardless of if you are requesting for an interface or the type, always new one. But what you want is that when you resolve a scope interface and a scope type, that they point to the same space in memory. So if I run the test, now my test passed, because I am resolving an interface, but they actually point to the same object in memory. This is so cool. Like literally, with this code is everything that you need to have an auto registration tool. This is everything that you need, and we have proven that with test. So in 30 minutes sharp, we just implemented a simple registration tool. Dead easy. Now, there are several things that can be added here. You can add functionality to, for example, add a tag. For example, you have two classes. One class that is going to be instantiated on your local and QA, and another class that is going to be instantiated on production. So why don't we choose create a new property here called tag, and we're gonna make this nullable, and let's just make this here. We can refactor this and just get like a type basically. Let's just call this public class registration or base registration attribute. And we can just pass this. We make this abstract and we just put this here and here, and we put this here, and we don't need this. We just need to call our base, and we're gonna do the same here. Let's just clean the stuff so we only add things in one. Just doing some refactoring. And with this, now we have everything in the same place. And I can add more functionality to a base class and use it in my inherited ones. So now what I can do is say that this attribute, if this attribute is present, I will register only if is the tag that I am using to register my library. So what I'm going to do is I'm going to first add here a list of tags. I can add a list of tags, and what I can do is I'm going to do something silly. I'm going to convert these tags I'm going to convert these into a hash set so I can search them in a performant way. And what I'm going to do is I'm going to check if this attribute has set a tag. So if this attribute doesn't have a tag, or the tag that it has set is in the collection of tags that I pass, then I am going to register. So I'm going to change this a little bit. I'm going to extract a function called if type is able to auto register, and I'm going to pass the type and I'm going to pass the tag set. There you go. What is this? There you go. So if I have a tag, I want to be able to register the type if there is no tag or the tag contains. So is tag is registerable by tag if the tag is null or the tag sets contain the tag. So I'm going to return if is registerable and it's a class that is instantiable. Hello Walid, how are you, man? So I'm going to also do exactly the same for the others. And with this now, I can go to my test and I'm going to add a test where I can register types that have tags. There you go. Now I'm going to create a service with a tag, and I'm going to make sure that if I register a type with a tag that is not tag 1, that this is actually not registered. So I want a test service with tag does not match. So I'm going to put a tag 2. Now my test should pass because my tag 1 is there. And obviously all the classes that have no tag, they are automatically registered. I'm good, man. Thank you for joining. I hope you're enjoying this, and if you haven't started watching this from the beginning, you can watch the recording later. So I'm going to make a test where my tool should not register types where it has a tag that doesn't match the tag that is here. So basically I am registering the tool with the tag 1, and I'm trying to resolve this, and this should be null because it shouldn't add it if it is tagged and the tag doesn't match the one that we passed. And there's a problem here. That's good. So what is wrong? Let's go here and check. So I am registering the type and the interface. No, I just register the type for now. I want to make this simple. Okay, so I can see that if I'm using the auto register type, my test passed correctly. But if I'm using my auto register type and interface, there is a problem. So basically it is actually registering when we use this tag. So let's go and fix this shit. Oh, because here we are using the type of attribute that is for types, but we also need to handle the case where we want to register types, interfaces, and type and interfaces. So I'm going just to put a little bit of generic here. And I'm going to say that T has to be of type-based registration, and everybody's happy. So what I'm going to do is I'm going to pass the auto register type here, the auto register interface here, and the auto register type and interface here. So if I save this, my test should pass, and it passes. So that's good. You can actually now have a simple registration tool that will allow you to register types, interfaces, types and interfaces, and you can actually filter so you don't register them all in. If you don't want to, you can just use some sort of filtering. This is really cool. Now, what about if you don't want to? What about if you have an assembly that has 100 types and you just want to register those that belong to a specific namespace? It's quite common, let's just make an example, to have services or domain or infrastructure, for example. And if you're exposing this library, you're exposing this DLL, you want to register types that belong to the infrastructure. So I'm going to create one test that will I'm going to create a test basically for this. I'm going to say that I want to register types that it should register type I would say it should ignore types if namespace is not in the assembly, for example. So I want to add autoregistrator. I want to use as assembly this one, and I want to exclude those types that are on domain. So I want to do now my domain service, and I don't want to register domain services. I want to skip the ones that are on my domain service. But you could say, oh, but you can tag them already. Yeah, but I don't want to go and tag all of them. I just want to make sure that if there is a class here that is not registered, because I have an easy way to say like, okay, if I have this tag, register. But I'm going to say now, if the class, the type, belongs to the domain namespace, don't register. Cool. So I'm going to add here a domain service, and I'm going to auto register the type, and this test should fail because I am registering. I'm going to say here excluded namespaces, and I'm going to do this. I'm going to allow here a string excluded namespaces, and I'm going to pass this as a collection. Cool, so my test should fail because basically my test is saying like, if there is a service that belongs to this namespace, it should not be registered. But because I tag it, it's basically being registered. So what I'm going to do now is I need to be able to pass here something that says that, okay, don't register. But I'm not going to do that here. I'm not going to pass anything. I'm going to go here, and I'm going to go and have my excluded namespaces. I'm going again to have a hash set of excluded namespaces, and I'm going to pass this hash set here. I'm using a hash set again to make a better search. And I'm going to have exclude namespaces, and I'm going to have tags. Now I'm going to have a boolean that is going to tell me if the namespace of the type belongs to any of the namespaces here. I'm gonna return false. So if any of the namespaces contains this, then I return false. Now, namespace, this is something interesting, a decision. The namespace could be null. A class could have a null namespace. This is a crazy decision, but it's real. So we have to account for that. So what I'm going to do is I am going to say that if the namespace is not null and it matches then I'm just gonna check if it's not null. Yeah, if it's not null and it matches any of the one that we pass, then no, it's not any, it's contains. There you go. So if the excluded namespaces contains the namespace of the type, I don't want to register that. That's it. So now let's just run the test again, and it's failing. That's good. That's good. Let's see why. Which one is failing? It's failing tag. And why is failing tag? Okay, so this is interesting. The test that was checking whether we can register something because it has a tag is failing. Why? That is because our extension method now has a lot of parameters, and I don't know if this tag is this or this, but because of the position, we are actually setting the tag into the excluded namespaces. So what I'm going to do is I'm going to actually change this, and I am going to make this private, and I'm going to add a new public method that is going to clean up this signature. So I'm going to add an iService collection, add auto-registrator, but here what I want to pass is an auto-registrator options that is nullable. And because it's nullable, I can actually not use it. Now, what I'm going to do here is I'm going to add into my options a list of my assembly. I'm going to add in my options the excluded namespaces, and I'm going to add in my options tags. So this way it's even clear what do we want to do. Now, there's going to be a couple of errors here, and you can see now that if I pass this type of option, now it's clear what I'm doing. And all of my tests should pass. Wow, not all of them. I just broke a lot of things. Okay, so what did it happen? Okay, yeah, so what happens now is that the assembly is probably different. Is it? No, it's not that the error. So what is the error? It should register all types in assembly. Just check this one, for example. Let's just check this. It should register interfaces. Let's just test this. Let's debug and see what happens. there is no assembly, no exclude namespaces, and no tags. Now, I can imagine what the error is. If I go here, I'm assuming, yeah, perfectly. So here we have assembly. The assembly is null. Let's see what get calling assembly does. This is returning auto-registrator. So basically, it's trying to find in this assembly what when we actually want is to receive the auto-registration test assembly. So we don't want to use get calling assembly, but I guess it's get entry assembly. I think that with unit testing, this can become a little bit a problem. So in order to make this actually work, what I am going to do is actually make mandatory for my auto-registration options. I'm going to request that the assembly is actually mandatory. And there you go. Now I make this mandatory. But what I'm going to do actually is I'm going to actually pass a collection of assemblies so I can register types in many different assemblies. There you go. Now, this is a little bit like, okay, how do I do this? What do I do? I need to pass now the assembly. Yep, I'm passing the assembly. And this is going to fix some of the tests, but not all of them. And this is going to be a list of assemblies. And if there are no assemblies, let's see what happens if we choose to do this. And for each assembly, I am going to register this. And this is services. I need to return here a service collection. Public static this. This is not used anywhere. Let's see. Good. All the tests pass again except this. Auto-registrator, it should not register types with tags when they're not required. So we broke the tag functionality. Let's see. What am I looking for tag 2? It should not register. Do I have anyone with tag 2? Yes, I have something without tag 2. So obviously that test is always going to stop failing. And this is tag 1. Perfect. Now my test pass. Now you can pass basically an option, but there is usually a pattern that is used more often, and it's not passing the options itself, but actually passing a configuration action for the options. And what you do is you will register options, you will create options here, auto registration options, and then you will actually you can exclude this. You don't make this required anymore. And you will, here you will invoke this action over the options that you just created. And let's rename these two options. And let's name this as configurator. Now, this doesn't receive the options anymore. What it will receive is options. I will set the tag. And here I will also set the tag. It should not register tags. This is tag 3. And here, what I'm going to do is I'm going to copy this. So this is usually what you want to do. This is the usual pattern to register and to work with libraries that you want to expose. If you look at how MediaTar does this, Fluent Validation, what else? Almost every important library uses this pattern of options that are configurable this way. So now you can have a tool that uses reflection to register types, to register interfaces, to register anything basically. And you customize the functionality that it does. In less than 1 hour, literally, in less than 1 hour, we added something that, you know, I find this approach way better than, for example, Scruton, or the old way of registering out of FAQ. Like 15 years ago, you were able to register things in out of FAQ with strings. You could say like register this type, and you pass the namespace, like the fully qualified name, and you say which interface you want to, you know. That was really nasty, XML all over, but that was really, really old. Anyway, if you are interested about this, you can find the code. I have actually published a library like this. I don't know, when was this? When did I create this? 6th of April 2024. It's more than a year ago. Yeah. More than a year ago, I created a library called Registrator.net that I use on my personal projects, and I know several other people that are actually using it. You can just go, if you want, just give it a try. You can try to replicate and understand what it does. You can just use it, basically. If you like it. I mean, there is people who doesn't like it. And there was a nice conversation on Twitter the other day where Aaron Stannard, which is the creator of aka.net, he actually mentioned that for him, this type of registration, auto-registration tools, it's like a code smell. And I understand where he comes from. And for me, what I get from a tool like this, that I can automatically just, like, when I'm working, usually my head is already thinking about things, and it thinks about, oh, this has to be registered as a scope, this has to be registered as singleton. I already kind of know where I'm going to. So when I do that, I would just go and say, oh, I want this, and I don't want to go to another file to add the registration. I just go here and say, yeah, you know, here I want to auto-register this. I'm going to register this as an interface, and I'm going to make this a scope, or I'm going to make this a singleton. And that's it. I don't need to find where to do it, because there is another pattern where you separate the registration of your services in one place, then your repositories in another place, then so you start registering things all over and you end up having 4 or 5 places, and then you put them all together. And I simplify my life just doing this. It's extremely simple. The performance penalty for using something like this is extremely minimal. Obviously, if you are going to be using this in a high throughput environment and your life depends on those 2 milliseconds, because literally this will take 2 more milliseconds than another manual registration, don't use it. Just be sensible and don't use it. But if you're not coding a high throughput application and you can spare 2-3 more milliseconds, just use this. There is literally no harm, or use any other tool. I am against conventional auto registration, like register all the types that ends with service and register all the types that do not belong to this namespace and then do this. So there is a whole world of complexity. For me, the tool has to be simple and has to solve the problem in a very strict way. That's why I like to use attributes, and that's why my attribute is basically, it has the lifetime here, it has a tag, and it doesn't use strings all over. So again, if you want to give it a try, just go and check registration.net. It's extremely simple. It's exactly kind of what we did here. It's been quite some time since I touched this, but basically it's just that. Services, auto register, types in assembly, you pass a configuration, and that's it. You say what do you want, what you don't want. Beautiful. So I hope that you like this. If there are any questions, I'm here to answer any questions. Otherwise, we're just gonna finish this stream, and I see you guys on the next one. No questions? Perfect. Have a great evening, everyone. I am going to walk the dog for the last time of the day.